Hi, everyone. Thanks for joining us for today's webinar on building your CI/CD test strategy with GitHub Actions. My name is Bill Hayduk. I'm the founder and CEO of RTTS. I have with me Jan Tacbianan, who will be presenting. Jan's an RTTS manager and a senior solutions architect who's been with us for about 8 years. Just a little housekeeping. If you have any questions during the webinar, please type them into the chat window. We'll answer as many as we can after the presentation. Also, please use chat to let us know if you're experiencing any issues. Thanks again for your time, and now we're ready to start. Jan, all yours.
All right. Thanks, Bill. Morning, afternoon, evening, night, wherever you happen to be. My name is Jan Tacbianan. As Bill had mentioned, I am a senior solutions architect and QA manager for RTTS. And today we'll be talking about building your test automation strategy using GitHub Actions. For our agenda today, we are first going to do a quick overview on CI/CD and GitHub Actions. Next, we'll be talking about full stack testing capabilities using the actions. Then we're going to talk about strategic pipeline design. And then I'm going to give a basic overview using the GitHub Actions screen and providing everyone with a demo. So first off, what is CI/CD? This is a very important part of this concept, because without CI/CD, then your whole test automation strategy will probably just fall apart. Since CI/CD is continuous integration and continuous delivery or continuous deployment. So CI is the practice, or continuous integration is the practice of frequently merging all developer code into a central repository. This is generally done with Git. So as we're using GitHub, when you have a trunk branch, a main branch, your default branch, that tends to be where everyone merges all their code in. Because everything's centralized, we can test everything from one central location. Once all your code is in a central repository, every time there's a change pushed, we have the concept of continuous delivery, CD. And this extends CI by automatically deploying all code changes to a testing and or production-ready environment after the build stage. CD is sometimes interchanged between continuous delivery and continuous deployment. Sometimes the terms are used interchangeably, but they are distinctly different. And continuous deployment is a fully automated process that releases every change that passes all stages of your pipeline directly to consumers. So for very fast projects, you may even have a pipeline that is code pushed directly to production based on all the steps in the workflow. All right, with that being said, what is GitHub Actions? GitHub Actions is a CI/CD platform within GitHub designed to automate, build, test, and deploy pipelines. So on the screenshot here, I have one of the PRs on the bottom left, and on the right is a sample workflow that I have for a pull request. Next, continuing with GitHub Actions, it is event-driven, so GitHub Action workflows are triggered by different events. So when you push code, when you make a pull request, if you have a schedule that you want to run your actions on, or you can even do a manual deployment. It is defined as code, so it's not a drag and drop system. It is written as YAML files, and because they are files within your repository, they are version controlled, so you can see when changes are made to your workflows. They're also flexible. Workflows work on GitHub hosted runners, or you could bring your own self-hosted runners. So that's great for those who are sensitive about putting information or having code execute outside of your on-prem environment. You can use readily available actions using the GitHub Marketplace, which I'll go over briefly in the demo, or you can customize your own. And also, the GitHub Actions are reusable, so actions can be reused across different workflows. Next, let's talk about full stack testing capabilities. So as you can tell, a comprehensive testing strategy can test the entire tech stack for a solution. So when you're thinking about testing, you can go through code level testing, service and API testing, backend and database testing, web UI testing, native mobile UI testing, accessibility testing, and security testing. I have a couple examples on the right side, some of the logos you may be familiar with. We have Selenium, We have Appium, Postman, so you can actually run Postman tests using Newman, which is our CLI tool. You have Apache JMeter. You have Google Lighthouse for accessibility and SEO audits. You have Playwright from Microsoft, and we have our tool, Query Search, which can test data quality. Next up, we're going to talk about strategic pipeline design with test automation. So there are three concepts I want to talk about. And first is shift left testing, a tiered feedback loop using the test pyramid, and to automate where possible. All right, shift left testing. So generally, when you think of a waterfall model, you'd think about what's going on the screenshot here: requirements, design, develop, test, deploy, maintain. There's also the same if you look at the DevOps or Agile loop. And shift left testing basically moves testing from the right side to the left side. So testing is more integrated as part of design and development. So with this concept, we test early and we test often. Shifting left means integrating tests into the earliest stages of the development cycle, and this philosophy is key to a successful strategy. Tests would run automatically on every code change, not just before release or as we are ready for UAT. They'd be actually tested every time we make a code change. And by catching bugs early, you dramatically reduce the cost and effort required to fix them, since you're finding them much earlier in the process. Next up, we'll talk about the tiered feedback loop. And this is using the test pyramid. So if you look here on this pyramid, I have code level and unit tests. So every time you make a change, you're going to have a unit test and code level static analysis. And as you deploy them or as you make pull request, we would work through integration and contract tests. So if you're thinking about your APIs, thinking about your contracts, making sure that the services work as expected without having the consumers or end users test the product. And your last step would be your end-to-end test. So once everything is fully integrated, everything's ready in a staging environment, then you perform your end-to-end tests. So I mentioned here, code level unit tests are run. Here's an example of where you can run them. Code level and unit tests can be run on every commit or every push to the repo. Your integration and contract testing can be done on every pull request, and your end-to-end test can be scheduled or run nightly. This depends on your deployment strategy. Maybe you'd want to run your code level or unit test maybe during your pull request. Maybe your integration test can be done. If you're only pushing every so often, you can actually run your integration test earlier. And end-to-end tests, if you need it to run more than once per day, you can run it definitely more than nightly. And last but not least, a topic I want here is the automate where possible concept. And there are many components that are overlooked when automation is considered. For example, when you think of things like bicep scripts or infrastructure changes, infrastructure as code, those changes can be tested. So say I'm deploying a new database resource, I'm deploying a new VM or app resource, we can actually test that those were deployed correctly. Sometimes you overlook those and we wait for the actual application to be available to test. Sometimes we have configuration that's deployed. So networking and access rules, those can also be tested. We can check the applications to ensure that they return 403 or 401 where necessary. And also security patches and updates. So these generally aren't code changes that you make for your application. These are patches or updates that are maybe your NuGet packages for .NET or your Node.js NPM packages are being updated. Those that don't have functionality changes or functionality changes that you're expecting, those can be automated, and you actually can push those along by automating your regression tests. Right, so the next step I'm going to have here is to go over our demo. So let me close PowerPoint here. And let me zoom in here. So I prepared two little demos here. The first thing is, actually, let me go into the GitHub Marketplace. So here's the GitHub Marketplace. You can actually filter by actions, and you can see there are plenty of options for deployments or testing. So there are run playwright tests, although they now recommend you just use the npx CLI. Maybe you want to run something with Postman. They have a Newman action, so there's an easy drop-in option for running your API tests. And also, for those who run or create mobile apps, you can actually deploy and run Android emulators on the GitHub hosted runners. You also have the option to do iOS. They have macOS available actions or hosted agents. Just note that the macOS agents, if you're doing the hosted agents, that it does cost about 5 times more than a Linux runner. So keep that in mind, but it's definitely an option. So you can run not just your web UI, you can run your native mobile apps, or if you want to see how your browser behaves on Android or iOS, you can do so here. All right, so the demo I prepared here is actually something I do for my personal blog, which is using a WordPress container deployed to an Azure web app. So the way I do that is deploy or create a Docker file, and then what it does is it takes the default WordPress container and then just pushes my configuration, my scripts, my plugins. For the sample here, I'm deploying the Windows Azure storage because with Docker, your data is not persisted. So having a plugin that uses Azure storage is ideal. If I go into Actions, I have 2 builds here. First is CI. So every time I'm pushing a change, that this would run. And on here, I can actually, you can see which steps I'm doing for each of the tests. So just setting up the job, checking out the repository. Then we're running static code analysis. So even before everything is being built, we're running a static code analysis. You have Dependabot on GitHub. You can also use NPX linting, so on and so forth. You can also do security scans. So there is GitHub Advanced Security. So you could run those scripts as well. Since it's PHP, there isn't too much to run here, but if you're having a more complex application, then you can add all your security tests here. Then you can actually build your Docker image and test it. So within the runner itself, have it run Docker, make sure that the image itself runs and executes and run basic tests. You could also run your integration tests here if you desire, but I tend to want to deploy it to a live environment so I can test things like configuration and app settings. And then here are the steps for logging into an Azure Container Registry and then deploying it or scanning for vulnerabilities and then pushing it to the repository. So that is the CI build. Here I have a deploy to Azure Web App. So this is done on pull requests. I have a build and test, which is essentially the same job as before. But then it moves on to a deploy stage where it deploys to an Azure Web App, performs a health check to make sure that it is live. Then we set up Google Lighthouse. So Google Lighthouse, if you even go on your browser and open up the developer tools for anything that's Chromium based, so Google Chrome or Microsoft Edge, you can see you can run a Lighthouse audit right on your browser. But this allows us to do accessibility and SEO tests. You can actually upload the Lighthouse report, and also it leaves a comment on the pull request itself. After this step, I have an example of running end-to-end tests, so fully automating tests here. I did make changes to my WordPress instance where one of the tests checks for branding, and I updated the branding name, so it does actually fail, which is good to see because we can see it actually behaving correctly. We have check out for repository, set up Node.js, install Playwright, running our Playwright tests. So you can see here, I updated the WordPress title to RTTS webinar demo. So it does fail because it's expecting WordPress. And then in the end, so it does fail here, but it allows the workflow to continue. If I go to summary here for this workflow, there is an artifact and it is the Playwright report. So you can actually open this up. It does have screenshots and videos of all the failures. So great way to audit your automation tests. And by doing a pull request, all your developers will be doing all this work, as long as the tests are all set up and there's no human interaction to get these tests run. Next up, I have this little workflow template. It doesn't do anything, but it should at least give you an idea of a complex workflow for actions. So here I have a CI build, and this would run on every code push. And here's examples of what steps you would want to run. You would want static code analysis and linting. your security testing, building your code, executing your unit tests, and then completing the job. So every time someone pushes code, we'd be running this build and ensuring that their code is secure and they're using reliable packages and that they're executing your unit tests. Then we have pull request builds. So what I like to do, at least when it's available, is to deploy to a pre-development or staging environment for pull requests. So this allows me to test things like infrastructure. So on this workflow, I have build application and start infrastructure deployment. So while the application is building, I am validating infrastructure scripts, deploying the database, verifying the database works, deploying a key vault, which is a secret store for Azure, verifying that the deployment succeeded, either by calling the APIs or just verifying that the resource is available. I also have my deploy web application to staging, which does run infrastructure scripts for creating the web apps and all the resources required for that in Azure. Once these 3 steps are deployed, you can see when I mouse over, I can see the dependencies. I could run my integration tests. This is just a quick smoke test to make sure everything, I can just reserve one simple agent for running quick tests. And then I have a stage for running regression tests. So maybe I have an on-prem runner that would be able to run all the integration tests for a particular deployment. Once that's all good, I can swap staging to main. And in this sort of infrastructure or staging environment, I can see what was the last deployed PR request. And the last example I have here is it's mostly the same as what you saw before, but this is deploying to different environments. So again, building your application and starting a deployment for your infrastructure. So in this particular example, I am giving, we're assuming there is a development which is done on your PRs, then an integration environment, your QA, UAT, and production environments. So integration environments, verify, run an integration test, swap to the production here means the main slot. Then we have an approval stage. Since I am doing this on my personal GitHub, I don't have access to required reviewers, which if you have GitHub Enterprise, you can put your approval step here. Start with your QA environments, UAT environments, and then production. And so in each of these cases, I have the ability to add testing steps to verifying my infrastructure is deployed, verifying that my web app is deployed and all the individual components of the infrastructure are tested. And I also have an opportunity to sort of break the flow with approvals or through these swapping steps to ensure that if there is bad code somewhere or there is a flaw that we don't want to continue through the flow, we can break it from there. I will clean this up, and this will be posted in a public repo on my personal GitHub if anyone's interested in seeing this. It is mostly just boilerplate code for a workflow, but at least gives you a good example of what's going on. All right. And with that, we go here. Anyone have any questions?
Yes, they do. I got a couple questions.
All righty.
First one, how do GitHub Actions compare to other CI/CD tools like Jenkins, Azure DevOps, or GitLab CI/CD?
That's a great question. The thing I would like to say is wherever your repositories are stored, if there's a CI/CD tool that's available to you, it is ideal to use that. So if you are already on GitHub, GitHub Actions is already available. As mentioned before, there is a large marketplace of various actions you can use. Uses a pay-as-you-go model for hosted runners, so there's no infrastructure you need to set up. It's all on GitHub. Jenkins is open source, so if you are focused on not having to pay for additional resources for automation, then you can use Jenkins to customize your on-prem solution. Very ideal also for on-prem deployments. And GitLab or Azure DevOps, if you're using those for your repos, you can again use those for CI/CD. Although if you are using GitHub for your source control, they can also use GitHub Actions since GitHub or Azure DevOps CI/CD or Azure Pipelines allows you to hook in your GitHub repos.
Next question. What are some best practices for managing secrets and sensitive data in GitHub Actions workflows?
That is a great question. If I go back to here with my example, if I go to settings, one thing that you can do here is add secrets. So these are secrets that are only available for your GitHub Actions. Another best practice is to use key stores, so Azure Key Vault. For example, if you're on the Azure deployment or if you're in AWS, there's a key store. I don't remember off the top of my head what is the resource name, but storing all your sensitive data in key stores is also ideal. So avoid hard coding URLs, client IDs, secrets, credentials. I even have names here so that I can change them on the fly, but definitely all my credentials are going to stay in a secret. To change these, it actually requires you to open up your GitHub app or use 2FA to verify that you are the one changing the secret or trying to access any of the secrets.
Next question. How can I test my GitHub Actions workflows before pushing them to the repository?
That's a great question. For actions, you can add to your workflows itself where you can make it so if you tag certain commits or tag certain pull requests, it does not run the action. With that, I would definitely make new actions to test that they work. There are also products that are GitHub Actions compatible. I think Git, for example, has a GitHub Actions compatible YAML runner, so you can verify those run. And there are also GitHub Actions that sort of can mock what the action would do. So those are just ways you can test. Of course, you can also use your own repository, clone or fork repositories, test your actions there, and then merge them up to the main repository.
All right, next question. If testing is being performed during the dev stage, doesn't that mean our QA teams will be less involved after dev is complete?
That is also a great question. So if I go back to the presentation, where we talk about shift left testing. Just because testing got moved to the left side, on the right side, this actually frees up your QA team to do tests that normally would be performed time permitting, such as exploratory testing, security testing, performance testing. By moving all the basic functional testing to the left side and testing it with automation, you have the opportunities to use your QA teams to support UAT resources, do more in-depth security testing, pen testing, and also run through test cases that would be considered edge cases are not part of the standard test suite, for example. So you're actually making better use of your QA teams rather than just using them in the beginning and then everyone is on standby for deployments.
Next one, are there any common mistakes or issues teams run into when setting up their CI/CD pipeline?
Yes. So as I mentioned before, it is important to test that your pipelines don't conflict with anything. When you set up your repositories, it is imperative that you set rules to ensure that one's secrets can't be used by workflows that they were intended for. So as an example of sometimes developers will see that there is a secret that's available, they add it to their workflow, and potentially that workflow goes rogue. So it's important to keep barriers in place for your secrets, barriers in place for your pipelines, and as long as those barriers are in place, any sort of testing or new experiments that you're doing with your actions, any of the impact is mostly mitigated there. But it's important to just have those guardrails in place so that the team is free to test things and see that they work. Or, of course, another way to mitigate that is just creating new repos.
I have a question for you, my own question.
Mm-hmm.
What's the best way to get up to speed in GitHub Actions?
The documentation for GitHub Actions is actually pretty good. So you can go through there. They can give you some tips on how to set up your own workflows. There's also a lot of public repos on GitHub, so it's can go on those repos where people have implemented actions, see what they do, see if it's something that you want to implement for your own actions. And of course, just play around with it. You can create a free GitHub account, and you can create public repositories and just test them out yourself. There's no cost to, at least as long as you're not exceeding the standard run times per month, it's free to run.
Nice. One more. How successfully can we integrate the shift left testing model while developing and handling last minute requirements?
So that, I guess it depends on where it is in the line. Of course, if your requirements are changing further to the right, then you'd have to just implement those changes as they're given to you. So let me bring up my PowerPoint again. So of course, if there's new requirements that are done after development or after testing is completed, then you can create the automation at that point. Or if you are time constrained, you would just do testing manually at that point and then automate it for the next iteration. CI/CD assumes that you would be, in an agile workflow, so you'd always have the next opportunity to add it to your regression testing. But generally, you want to make sure your test cases, your automation is sort of started in the design phase and worked on during the development stages, so that when they're actually moved to further environments, that they're ready to use and ready to execute.
Great. Well, that wraps up our QA session. Thanks again, everyone, for your time and participation today. We're going to be sending a follow-up email to you with a link to the recording, the slide deck as a PDF, and our contact info in case you have any additional questions. Thanks again, and have a great day, everyone.
Thank you all.